Welcome to section A3, exception handling. This is where you learn how to handle errors in Java, not just prevent them, but actually catch them, understand them, and keep your programming running when things go sideways. Here's what you'll get from this lesson. You'll understand what an exception is and why it matters. Learn how to use try-catch blocks to safely handle them, and recognize some of the most common exceptions you'll encounter in Java. Let's start from the top. What's an exception? An exception is an error that happens at runtime. When the program is already running, it disrupts the normal flow and can crash the whole program, unless you do something about it. Why should you care about handling exceptions? Because if you don't, Java will crash your program. It will stop running and dump a stack trace to the console showing exactly what went wrong and where. It's not a good look for your program, especially if users are involved. In this example, the following stack trace is printed. Exception in thread main java.lang.arithmetic exception /by0 at com.example.exceptionhandling.main exceptionhandling.java : 4. This throws an exception because you can't divide by 0. The program ends right there. Line 5 is skipped. So what really happens? Java throws an exception when something goes wrong. If you don't catch it, the program stops. You get a stack trace like exception in thread main, Java lang arithmetic exception, division by 0. You've probably seen something like this before. So how do you deal with it? Well, sometimes the best way is to avoid the exception in the first place. Like this. If divisor is 0, then print can't be 0. Else, system println 5 divided by divisor. Simple logic saves the day. But sometimes you can't predict what's going to happen. That's where Java gives you a tool, the try-catch block. It's like saying, try this risky thing. If it fails, do this instead. Java exceptions come in two flavors: checked exceptions and unchecked exceptions. Checked exceptions, the compiler forces you to handle them. Unchecked exceptions, you don't have to handle them, but you should. In exercise 1, add exception x1.java to a new project. Run it and see what happens. You likely get an array index out of bounds exception. Is this exception something you should handle? Try modifying the program to avoid this error, or compute the array's sum safely. Let's get into the try-catch structure. You write risky code inside the try block, then you write one or more catch blocks to handle specific exception types. The format of try-catch block is try, then open curly braces, the risky code is written there, then catch block with exception type, and the curly braces, how to respond. When things go right, here's the flow. The try block runs, no exception occurs, Java skips the catch block, execution continues as normal. When something fails, the exception happens inside the try block, Java jumps immediately to the matching catch block, skips the rest of the try block, then continues after the catch. In this example, a try-catch block was added to catch arithmetic exception. The example illustrates the program flow when the exception is handled with try-catch. Arithmetic exception occurs at line number 9. The control immediately passes to the catch block. Statement number 10 in the try block isn't executed. Statements in the catch block are executed instead. The execution program continues with the statement outside the catch block, and after catch block is displayed in the console. Here are some common exceptions you'll run into. Array index out of bounds exception, accessing an existing index, null pointer exception, using an object reference that is null, IO exception, something goes wrong reading or writing files. This code shows a common mistake made when accessing an array. Remember that arrays are zero based. The first element is accessed by a zero index. Therefore, in an array with 5 elements, the last element is actually int array 4. So int array 5 tries to access an element that doesn't exist. Java responds to this programming mistake by throwing an array index out of bounds exception. And the stack trace is printed to the console. Because accessing an invalid index in the array is an unchecked exception, you don't have to handle the exception with a try-catch block. A null pointer exception is thrown because a method is being invoked on a null value. The slide example is handling the possible raised exception by throwing the exception from the test checked exception method, catching the exception in the caller method. In this example, the catch block catches the exception because the path to the text file isn't correctly formatted. So system.out.println E calls the toString method of the exception. And the result is java.io.io exception. That is, the file name, directory name, or volume label syntax is incorrect. When catching exceptions, it's best to be specific. Catching just exception works, but it's too broad. You won't know exactly what went wrong. The code in the slide illustrates two poor exception handling practices. The catch clause catches an exception type rather than an IO exception type. The catch clause doesn't analyze the exception object. Instead, it simply assumes that the expected exception was thrown from the file object. As a result of this careless programming style, the code prints the following message to the console: there is a problem creating the file. The message suggests that the file wasn't created, and indeed any further code in the catch block will run. But what's actually happening in the code? The code illustrates two good exception handling practices. The catch clause catches the IO exception type. The catch clause prints the exception details to the console. In exercise 2, add calculator.java and shoppingcart.java to your project. In calculator, modify the divide method to throw an exception when division isn't valid. In shopping cart, handle that exception with a try catch. This gives you both sides, throwing and catching exceptions. To wrap it up, you now know what exceptions are and why they really matter, how to handle them using try catch, what types of exceptions you'll run into, and how to write exception-safe code with good practices. Remember, the goal isn't just to avoid crashes. It is to write programs that recover gracefully when things go wrong.